Amfeltec Squid, what, why, and how. Unboxing, installation, inspection, and test. Been a long time getting to this card. As we answer the what, why, and how, we've got 3 questions we're going to answer for subscribers' questions. First thing we need to do is get this out of the box and see what we've got. And this is the unboxing, the unveiling, all the way from Canada. Took a little while for this to get here too, but it's taken even longer for us to do the unboxing. This is not a card you're going to find unless you know about it. And the first question asked was, when we were notified or made aware of the card, was, what do you think of it? I've never heard of it. I don't know squat. Let me do some research, look into it, and see what it does. I said, well, I still don't know enough about it because the information they've got on their website is, well, they could do a little bit better in my opinion. All we know right now is the Amfeltec Squid is a PCI Express carrier board for M.2 NVMe PCIe Express SSDs, and it will hold 6 drives. And that's pretty wicked. Now that means this has a PLX chip on it. So the next question that comes up, how does all that work? Let's get this unboxed. We'll go through some of that. Every question with an answer brings up more questions. And this is not like any mass-produced product that we're used to seeing. Amfeltec. And a little feature we'll get into when we get inside the box. This says Squid Generation 3 Carrier Board 16.8. And of course the SKU on this. The SKUs are a little bit difficult when you're ordering this to know what you're getting. The box is sealed, so we're going to break that seal open. And again, to reiterate, this comes from Canada. For those that are aware of what Amfeltec does, because the next question that came up is why this card? Well, we started this when we were looking at these add-in cards 1, 2, 3, 4. And for those that asked the question, specifically, what does this do? What do these type cards do, in fact, in general? Okay, we've been looking at dual M.2 NVMe adapters. Before that and after that, we've been looking at quad M.2 NVMe adapters, which means you can put 4 drives, 4 M.2 NVMe drives into one 16-lane slot. One 16-lane slot, not just mechanically, but electrically, and that's the key, because a lot of motherboards don't have the resources to do that. Okay. Because most of those cards, and this brings up another issue because there's a lot of information in play, because most of those cards that I've just mentioned require motherboard bifurcation, there's another kind of bifurcation that's required if your motherboard does not have the resources to do that bifurcation. And that is what this card can do. It is self-bifurcated. So this card has the ability to work on a 16-lane slot, which all of them do, but we can configure this card if the part's there, and it says it is according to the part number, that we can configure this to work on an 8-lane slot. Now, we've only looked at one other card that is self-bifurcated, and that was the one by Glotrends, the Glotrends Sky card. It's self-bifurcated. This is a higher-end custom-in card, and this is manufactured in North America, in Canada. So I'm excited about this. And another question from another subscriber came up, and Amfeltec is the one that can deal with that, which seemed a little odd in the beginning, but does anybody make a card that will work in a 4-lane slot that is self-bifurcated, which is a pretty tall order, which at the time I said, I don't know, I'm not sure, I don't think so, but if there is, there's one manufacturer that might, and this is the manufacturer, Amfeltec. They do make a card. I'll have the link up in the description. There's not a lot of information about this stuff. You can only buy Amfeltec Squid from Amfeltec Direct. In fact, they don't even have the prices up there. It just says quote. So, you know, if you got to ask how much, they're proud of it. They were proud of it before all the funky stuff going on, and I'm sure they're even more proud of it now. And as difficult as it was then to get this over the border, it may be more difficult now. But anyway, the point, they make a card that'll work in a 4-lane slot that's bifurcated that'll take 2 drives, which is pretty wicked. Now, what's special about this is that we can put in 6 drives. So we're going to use the 4 drives of one spec we've been using and the 2 drives of another spec that I will outline when we get to that point to put all 6 on this drive. Now, series of tests we can do. The tests are, I'll talk to you about it when we get to it. Let's get back to the unboxing because I know someone's going to fuss. I want to see the card. I hear you. So we'll do our ribbon uncutting, cut the seal, and I don't have to worry about anybody else messing with this because this is straight from Amfeltec. Super nice people to communicate with too. We got a manual. Nice. Now what I would like to see is that manual as a PDF on the website because it would make it easier for me to bring it up on screen. But we're going to have to work with what we've got. And the parts. I had to be careful about the SKU because the way you order the parts, I want to make sure I had everything for the presentation of what I wanted to share with you guys. And there should be more parts in here than what we need. Okay, this is a key part, the by 8 adapter. We're going to set that over side. This is a part. Let's zoom in on some of these parts so you can see the SKU. This is the part for the PCI Express 12 volt power cable. And this is the part for an ATX 12 volt power cable. And you can see how that works out. There are different types of power cables. I've got one here that'll take it straight from the bus. I've got one here that'll take it from a power connector, straight from the power supply. Then I also have the USB terminal cable. We'll get to that more here in a bit. That looks like a standard USB cable on one end for USB 2 and a special little pinout that goes on the card. And I haven't seen one of those since the days of when we were using the NEC CD-ROM drives that were SCSI. Wow, that takes me back. For communication, we'll get to that when we come to it. And for the important part, the piece de resistance. And for something that we're all very concerned about because we've been looking at M.2 NVMe heat sinks, and those look very familiar to some heat sinks we've looked at in the past. Now then, so that we can get a good clear scope on all the documentation, I'll zoom in as best I can and I'm going to read as much of it as I think is necessary. Note, heatsink installation on the M.2 NVMe SSD modules for the Squid carrier boards with the SKU, part number. It's crucial to have airflow around each M.2 NVMe SSD module to avoid module overheat. This package contains heat sinks for each SSD module. Please install them on the top surface of the module as close as possible to the M.2 connector as shown in the diagram above. And we've always been concerned about our spacing from left to right. Now our orientation has always been where the screw is, and we have that always turned around the other direction. But to keep this orientation, which is opposite of what we show when we're hooking, because the way it hooks on everything, I'll keep it this way so we can read it, and I'll keep reading. Now this information I don't remember seeing on the website, but I'm glad it's in the box. And while we're on that topic of heat sinks, remember, this is PCI Express 3.0. So of the three things that can define the speed of one of these meaning an add-in card, which happens to have 6 drives. And remember, each M.2 NVMe drive requires 4 lanes. So 4 lanes per drive, 4 times 4, that's 16 lanes. So we're going to take 16 lanes with an uplink and a downlink through the PLX chip, manage 6 drives, because this has a Broadcom chip. And the Broadcom chip is what you'll see on some of the higher end cards, like the Gigabyte Aorus Extreme. It's going to have 8 drives. Still waiting for that to come out. And then, of course, the high point cards that can do 8 drives. Both of those are using a Broadcom chip. So it's relevant. I want to mention it because of the 3 things that control the speed. One, and I'll show you as it relates to this machine with the other cards once we get this part done. But one, to reiterate, is the speed of the PCI Express bus. Okay, the machine we're going to work on is the Gigabyte TRX40 Designare, where we have 2 16-lane slots dedicated and 2 8-lane slots dedicated, all dedicated resources. And we have 4 M.2 NVMe drives. Now I'll go over all that again once we do an overview of the motherboard that allow us dedicated resources. There's nothing shared. As we looked at the last chipset and probably the next chipset, all that stuff that's shared, it's like who's on first. You got to figure out what you can do. There's a lot of stuff you can do, but you can't do everything at once. Well, with this, we're going to do as much as we can at once. Now, I want to test this 2 ways because of the 3 things that define the speed that I'll go through again because it's important to understand this. Number 1, the PCI Express bus of the motherboard, which is a chipset. Number 2, the speed of the drives, of which we're going to use 2 different types of drives. And then number 3 would be if the card, as this add-in card, has a PLX chip, that is your governor. That's what throttles the speed. And because this is PCI Express 3, no matter what drives we use, even if it were all the way to PCI Express 6, if such were available now, we are still limited by the governor on this card, which is the PLX chip, which is PCI Express 3. So we're going to be looking at about 3,500 megabytes per drive. So as we get to the test, one of the tests we're going to do, where we can put that up on screen, where we'll look at our speed and heat, we'll be able to see the smart telemetry as it comes through. So we can look at heat and we can look at speed of the individual drives, 6 drives. Then when we repeat the test, what I'm going to do is I'll cut that part out so you guys don't have to watch, because it's going to take me a while to do all this. I want to show you as much as I can and tell you as much as I can, because this is an extraordinary piece of technology, and it's absolutely fascinating what it can do. Because for those of you that have motherboards that have shared resources, as we went through in the last chipset with a Z590, where you've got a 16-lane slot and you've got one 4-lane resource where you got 20 PCI Express lanes. However, when you bifurcate that slot, that primary slot, and you put a quad adapter in there, you only see 3 drives. So to see 4 drives, there's 3 on the quad card and 1 on the motherboard, instead of seeing 5 drives, which I think is nuts. Well, with this, you can leave that slot in auto mode, so you have full 16 lanes. And because it's a full 16 lanes, you can put it in a 16-lane slot, or if you have 2 slots and they're shared resources, by 8, in other words, by 16 electrically single slot, or by 8 by 8, when you have 2 slots, you can configure this to work in a by 8 slot, and you still can put in 6 drives. So I think this is phenomenal. Yes, this is an expensive card, but this is about the technology. So let's get back and take a look at it, because we got a lot of stuff going on here. And I've been really eager to share this, but I didn't want to share it until the timing. And I thought once we hit PCI Express 4, it wasn't relevant. But with all the new motherboards coming out that are PCI Express 4 and PCI Express 3 mixed, this is very relevant. I think even when I placed the order for the card, I think it took about 2 or 3 weeks before it finally shipped. And then when it did ship, it took a little while to get through the border. Okay, let's look at the layout and the design of the motherboard. Okay, this will work, and we'll have 3 drives on one side, and then we'll have 3 drives on the other side. Now this will work with the 2280, but this will also work with the 22110. We just had to move the screws over, which is kind of nice. Notice there's a couple of fans on the end, and they make comment about this. If you're in a machine, and again, of course, our machine is going to be open, where if you decide you have sufficient cooling in your machine, it's closed, and you've got large fans, because larger fans blow more air, but they make less noise, then you can disconnect these 2 fans. However, if you're in a closed machine that does not have good airflow, then you can use those 2 fans. Okay, as always, we're going to configure this in a default configuration, and I want to do this both ways, where we can use it in a 16-lane slot and an 8-lane slot. And because the motherboard BIOS in this system, which is the Gigabyte TRX40 Designare, does bifurcation, then what I have to do to use this in a 16-lane slot, I have to unbifurcate that slot. So what I want to do is, since the 8-lane slot is not bifurcated, oh, yes it was, I take that back. The 8-lane slot was bifurcated because we were using the Supermicro, and that's the dual M.2 NVMe adapter. So both of the slots, both the 16-lane slot and the 8-lane slot right now, are still bifurcated. I forgot about that. What I was going to do is put this in a machine, get it up, do one test while I was there, change the bifurcation, and I just realized while I was telling you about it, both slots are bifurcated. So I've got to power on the machine, go into the BIOS, unbifurcate those slots before I can stick this thing in either slot. Details. Change one thing, changes everything. And the chipset is over here under the heat sink. I'm not going to take it off so we can look at it. We just know it's there. And it's a Broadcom. I'm not sure which one, but because of the way it's programmed and the way this is designed, it will allow us to do what we need to do. And there's the connector for the power right here, and I was concerned about that. And then the connector for the USB, right there, little rascal. There's the connector for the USB, and there's the connector for the power tap right there. And of course on the PCB it says revision 1.1. So, and even though this is PCI Express 3, Amfeltec has said that yes, they're going to do PCI Express 4, but PCI Express 5 is coming out, and I want to interject this right now. The first PCI Express 5.0 M.2 card, qualified that I've seen or heard wind of, and I'll put a link up to an article about it, is the one from MSI, where it's going to support 1 drive, but it's 1 drive in an 8-lane slot, which means 8 lanes, you're going to lose 4 lanes. But it is what it is. The card looks amazing. They've already talked about heat, but it's only got 1 drive on it, which is kind of wicked. But that 1 drive will be connected to the PCI Express bus, connected to the CPU, which is crucial because as we get into the Z690, I think this is going to be a lot more confusing than what we did on the Z590. So let's get this assembled. We're going to put 4 drives on it. Now, this is where things are going to get really interesting. Because we're going to do 4 drives, what I want to do in drive 1 and 2, which would be, as we look at the numbers, we have, it looks like number 5, number 9, and number 10 I'm going to flip it over right quick and let's see what we've got on the other side. We have number 8, number 6, and number 7. My hopes is that these are set up for consecutive installation, which would be 1, 2, 3. But it may be the opposite. So when in doubt, we'll take a look and see what the manual. Ah, I like this. Now I wish their website was laid out like this. Whoever did those 2 pieces of documentation needs to get together. This is much better because I'm seeing this piece of documentation for the first time as we open this up. I don't care for the way their website is laid out. I think it's a little bit difficult to navigate, but that's just me. I like to keep things simple and make it work. We'll answer this question right quick since it's in here. They make a card for 1 M.2 NVMe PCI Express SSD. They make a card for 2 M.2 NVMe PCI Express SSDs. Then they make a card for 4 M.2 NVMe SSDs. And I need to interject at this point, there is another card that is in concept stage with IC Dock. I'm going to put a link up in the description so that if you guys are interested in seeing a quad card from IC Dock, now's your chance to give them some feedback. So I'll put those links in the description. But it was relevant at this point because I like to keep up because I find this stuff fascinating, what's going on. And it's just like, one piece of information leads to another. If I went searching for that, I'd never find it. I stumbled upon it because I get stuff from IC Dock. I use a lot of IC Dock stuff, but I digress. But it's relevant. Another nice thing about this card is because of the bracket and the way this is designed, even though there's 2 drives on each side, it comes with a low profile bracket, so this will fit in a 2-unit rack. And it also can be configured to work in a 16-lane slot or an 8-lane slot. As it says here, a by 16 upstream adapter and a by 8 upstream adapter, which is optional. Optional is the key. You got to look for the SKU to find the part. I want to point that out because that's what we did for this particular one, where we have the ability for 6 drives. So again, to reiterate, the stock is the by 16 upstream adapter, which is as configured, but the optional part is so this will work in a by 8 upstream adapter. And again, optional. You have to look at the SKU. And as it says here, operates in any motherboard, supports M.2 NVMe PCI Express SSDs, 80 millimeters and 110 millimeters. Easily removable cooling fan with dimensions with and without the fans. And as far as the width of the card, it'll fit and it's not going to be an issue. I wish the heat sinks were a little bit bigger, but that's something we've talked extensively about. We're going to be seeing a lot more of with heat sinks. And there are other SKUs, other parts in here because I want to address the question about a 4-lane slot. Okay, the card I was looking for that I wanted to show you, I don't see in this catalog, but I'll have the link up specific on their website that shows that particular card. This manual must have been printed ahead of time. That again works in a 4-lane slot, according to what it says on the website. Okay, the manual is nice, but the manual is not a PDF like a document about the card. The manual is more a nice manual, sales manual, but we needed to look at it. So the default configuration is the by 16. So what I want to do is then I will start with a default by 16. We'll test that. Then we'll change it to the by 8 and we'll test that. And then we'll do the third set of tests, which will be in RAID mode. Wow. We really need to test the RAID mode in the by 16 and in the by 8. Wow. Okay. I'm game. Hadn't thought about that. And for those that comment about the IOPS when you go to RAID, remember, there's 3 types of RAID. There's a hardware RAID. This is none of that. The other 2 types of RAID are software RAID. With this, we can configure a hybrid BIOS RAID, or the simplest solution is the operating system RAID, the RAID in Windows. It's the slowest, but it's the easiest. We will configure this as a hybrid BIOS RAID, which is a combination, but it's slow. If you want real RAID, because this is a poor man's RAID, you want hardware RAID, and that's on a Broadcom card. And the part to make all that work is now becoming available, but man, it is as expensive as just this card alone, which is the docking bay, because I had one user talk to me and ask about it, and he said, I don't need hot swap capability. Okay, the issue with the Broadcom card, as they are designed out of the box, they're made for NVMe, but they're designed for U2. There's a difference in U2 versus M.2. And as we've shown in the hardware RAID card video that we did using the Broadcom card, 3 components are required. 1, the Broadcom card. Number 2, was a special cable that has to be ordered, and there's a link that's in the video about that, from ICDoc, another vendor that they use to custom make that cable. And I said order that part first because it's going to take a little bit of a lead time. The third component, the crucial component that is now just becoming available but is a bit pricey, is a dock from ICDoc that puts 4 M.2 NVMe drives in one 5 1/4 inch bay. Yes, it makes them hot swappable, but it makes that Broadcom card, because of the cable and because of that rack, where you can change it from a U.2 to an M.2, which is pretty wicked. Because of the probably 3 or 4 technology holes we've had in the last, I'd say maybe 30 years, this has been number one that's been RAID to go from SCSI RAID to M.2 NVMe RAID. And to have access to that now, that's why we waited, is phenomenal. Back to the card. So we're going to need to get the other card out, pull the drives off of it, so that we can put the drives on this card. So the other 4 drives we're going to be using are on this Aorus quad card. Those 4 drives, plus these 2 drives. And I'll get into the specs in a minute once we've got them all laid out. All 6 of those drives are going on this other card. And we got to remember, we've got to go into the BIOS and turn off bifurcation on both of those slots before we can set this up and do this. Interesting looking at the 2 cards as they look side by side. I'm looking at the numbering on the card, trying to decide how this sets up, because on the front side we've got U5, U9, and U10, and on this side we've got U8, U6, and U7. Actually, that would be number 1. 1, U5, U6 would be 2, and then number 7 would be 3, U8 would be number 4, and back over here 5 and 6. So what I'm trying to determine, I want to keep this what I'll call apples and apples, and I would like on the first 2 connectors, don't know if it matters or not, but I want to put the 2 highest performing drives. Now, because of the again of the PLX chip, so I'm going to keep bringing that up so you'll get used to it. Because of the PLX chip, we're PCI Express 3.0, we're good for about 3,500 megabytes. So we're going to use 2 different types of drives, or 2 different specifications. Both are PCI Express 4. However, the first 4 drives that we're going to put on that will be on connectors, say 5 through 6, those are PCI Express 4 first generation, so they're good up to 5,000 megabytes. Whereas the other 2 drives, so they're good for almost up to 7,000 megabytes. And if we had 3rd generation drives, PCI Express 4, they'd be like 7,300 megabytes. Okay, so what we want to do is look as we test each one of the drives and see if we get consistent about 3,500 megabytes from each drive. 4 drives in RAID theoretically would be 5, 10, 15, 20. Okay, 4 drives in RAID will be the speed of 3, which is 5, 10, 15. I say that and explain it that way because I've had to go into that detail when I said just the short form of that, and other people said, can you give some clarity on that? So I hope I just did. So to reiterate, I want to, if the numbers are correct, and if what I think in my head that I'm reading is correct, I want to follow that 1 and 2 as it defines the connectors on the board, which means 1 on each side for 1 and 2. The other 4 goes as it goes. And then once we test individually, then we'll put them in RAID and we'll test it collectively. But remember, in RAID, because we lose smart thermistor technology access, we can't test heat. The only way to test heat is if we had thermal conductivity readings where we got the card up out of the machine. We've been through all that. We have a riser bracket, but the riser cable for PCI Express 4 does not work. Now, we've also shown that Gigabyte has a riser cable for PCI Express 4 in their 2-unit, I believe that was a TRX40. And I'd love to get my hands on one of those. That would make something like this where we could get it up out of a machine where we could test. But until we do, we work with what we got. So first test, heat and speed, reading off the thermistor. Second test will be strictly for speed. We're not worried about capacity, although yes, we'll make note of it, see what kind of partition we've got. This should be wicked. Now all we need to do is get this disassembled and pull these drives out. And the black tape was on there from a thermicity reading we were trying to get off these cards. I really like the way Gigabyte built that card with that giant copper heatsink in there with that huge thermal pad instead of strips. Oh, and that reminds me, our chart that we have with the heat sinks and with the 3 quad adapters, I'll put that up when we get to that point. Almost forgot about that. Black in here, Max, and some of you guys in my head asking, well, what about and what if? Part of the what, why, and how with the coulda, shoulda, woulda. we got you covered. So the first thing, I'd love to zoom in on this, but I want you to be able to see, because I don't want to just have these laying here loose, but I'll get them all ready, and then we'll transfer them over. All right, we're going to go for number 5 and number 6, and that will be off of the Supermicro dual M.2 NVMe adapter, where we have the WD Black SN850 and the Samsung 980 Pro. And these two are the fastest drives we have tested, but these are the two drives we've tested consistently with the heat sinks. And the whole heat sink thing started looking for heat sinks for a dual M.2 NVMe adapter, and then went to quad adapters that didn't have heat sinks. So we're going to start with this drive. That is a really nice adapter, the Supermicro favorite. And we're going to put this, now what I don't get, the fasteners they've got, the way the screws work, there's no way to put a wrench on these. I'm going to zoom in as tight as I can. There's no way to put a wrench on these. These are strictly finger tight. And you can see the screw, how those are offset on those connectors so that they do not interfere with each other. And that first connector we're going to go for is U5. I've never seen fasteners that did not use a screwdriver. Just one of those little details. Okay, U5, drop that in. And there is a top and a bottom to this fastener they use. I appreciate the attention to detail, but that ought to be something I could put a wrench on, and that should be a standard component part. Okay, that one's down, but you can see how that looks. There's nothing there to get a grip on. It's just, it is what it is. It's round, but I can get it finger tight. Okay, and I'll go one on the other side. So that's number 5, and looking for number 6, which would be right here. So we'll take the second drive, and the WD Black SN850 is a little faster than the Samsung 980 Pro, and both the WD Black SN850 and the Samsung 980 Pro have had firmware applied to them. We had to restore performance on one of the quad cards, but it was not required on the Samsung, but because we were testing both drives, we went ahead and applied the firmware. Samsung had, I think, a little bit better instructions on the process of what to expect updating the firmware, where they talked about rebooting, whereas the WD Black didn't bother to mention, oh, by the way, you might want to power down and reboot, or else performance is going to be like SOL. But from past experience of things like that, we did that, and yeah, it worked. But we went the full course, the full Monty, just like doing a BIOS update. We shut the machine down, powered off, pulled power, drained power, put power back to it, brought it back up. Performance was restored. Otherwise, on that quad card, it was the same problem that was talked about on the, I believe it was the X570 chipset, where if you had the WD Black SN850, which can be two ways, to the CPU, was not necessary for the firmware, or through the chipset, on the quad adapter, which on the Gigabyte TRX40 Designare is on a PCI Express dedicated 16-lane slot to the CPU, exhibited the same behavior as if it was on the X570 chipset through the chipset. So firmware update solved it. But I go through all that so you'll know, because that's an important detail. Okay, number 2's on. Right. The other 4 don't really matter, so all we need to do is just extract and move. I want to try to keep this zoomed in as much as I can so we can focus on the card at hand. Now, these drives are all going to be Sabrent, and I'll go over the specs on these in just a minute here. I like to reiterate that point so there's no confusion on the spec. I got to tell you, you've got to have really nimble fingers to get these little threaded bushings back on. Can't call them nuts because there's no way to put a wrench on them. You just put them down and finger tighten them. That's kind of weird. Something else I need to note that I have not on the Samsung 980 Pro and also on the WD Black SN850, those are single-sided. I don't think I've mentioned it before, but these Sabrent Rocket 2 terabyte drives, which are PCI Express 4 first generation, they're double-sided. And I never had mentioned that before, but I should have. Because all the heatsink tests we've done have been with single-sided, but these, to reiterate, are double-sided. So that comes up again. And the reason it's relevant, I think, is because the new Seagate FireCuda 530, those are double-sided, my understanding. And those are PCI Express 4.0 third generation, which puts them at 7,300 megabytes, in other words, 7,300 megabytes per second on the read and almost 7,000 megabytes on the write. Those, in fact, that brand and two others, there's three. Those are the fastest right now. There are links in the other videos. Since I've mentioned them, I'll put up the links in the description. Okay, that's 3 drives. And I'm going to be curious to see how these are seen in the BIOS according to order. So back over to the other side, pull off the other bushing, get the other 2 drives set. It's interesting, the creative design they've given this PCB. I guess that's kind of supposed to be part of the Amfeltec logo. I don't know. For what this thing costs, it ought to come with a little gold monkey. But it's an incredible piece of technology. If it's something you need, period. If you have a motherboard that does not have dedicated resources and you have shared resources, this will be a card that will give you capacity and performance. But it's PCI Express 3. I can tell all of these cards, nobody plans on anybody ever taking them off due to some of the quirks. And this is one quirk I'm not fond of. I'm curious because the way these bushings are designed with a flange on one side, I wonder if they made that flange for a reason, for fit, and no, that's loose. So that, I thought maybe they had them upside down for a reason. They're upside down for a purpose. The flat side, let me see if we can zoom in on that. I'll put that on edge. If you'll notice, to the left has a flange on it. That flange was facing up. I thought maybe it was supposed to be facing down for this, but no, it's supposed to be facing up. So I want to point that out. I tried it. It's loose. Sometimes these engineers, you think, okay, who's the genius that came up with this idea? How about we have this bushing with a, which means it'll have to be a little bit taller, either to put a Phillips head on top of it so we could take it and put it on there and put it down, or how about a nut instead of a bushing that has some sides on it so we could put a wrench to it and just give it a little bit of a twist. I'm just saying. So the first question that we've been asked, what do you think of the card? Let's see what the tests say. For the second question, why this card? I hope we've kind of covered all that because it's extremely relevant. And then the third question about, do they make a card that works in a 4-lane slot that's self-bifurcated? Yes, they do. But they're the only ones I'm aware of. But then again, I wasn't aware of this till somebody told me about this. This is kind of like the Honey Badger. Since I've mentioned it, I'll put a link up. The Honey Badger is something strictly for servers, another conversation. Now I've got to get the Gigabyte card back together and get it out of the way so that it will be ready for later. Because another question has come up about, have you ever tested, and I'm going to answer that one again, 2 of these quad cards in a machine? No. Couldn't do it until we had the TRX40. But to do that, that means I've got to put the video card in an 8-lane slot, which I don't have a problem with doing, but I haven't done it yet. And then the next question, have you tried 4 of these cards in a machine? No, I have not yet. But to do that requires a WRX80 because I would have to have 4 16-lane slots electrically, not just mechanically. A lot of people don't realize just because you got a 16-lane slot mechanically, we have to look at the resources and see how that's laid out. Because if they're shared resources, I can't believe what y'all put up with on Intel. So I'm really eager for us to get into the Z690 chipset because it's going to be more complicated than what we did in the past with the Z590. But with the Z690, you have the option now of having 16 CPU cores, and you get PCI Express 5 to some extent. That's still kind of a work in progress. Makes good advertising, makes good marketing, and that's one thing Intel excels at. Thunderbolt's a good example. All about marketing. If AMD ever figured out marketing, they'd be dangerous. But I digress. We have our 4 drives secure, and we've installed them based on what I perceive as the connectors according to orientation for 1 and 2. And then, so to reiterate, we have a WD Black SN850, we have a Samsung 980 Pro, and those 2 drives are PCI Express 4, 2nd generation. So they're capable of almost 7,000 megabytes on the read. The WD Black a little bit faster. Now the other 4 drives, these PCI Express 4.0, 1st generation, and they're capable of 5,000 megabytes per drive. However, because we have a Broadcom PLX chip on here, the best we're going to get out of all those drives should be around 3,500 megabytes. So from 3,500 megabytes to what it was. However, we're getting 6 drives on one 16-lane slot. But that 16-lane slot, because of the PLX chip, 2 things. 1, it's self-bifurcated, but 2, it's also the bottlenecks because it's PCI Express 3. So we're going to see how this plays out. And we're going with the default, the 16-lane slot. And after we've done the hocus pocus with that, we'll come back and test it on an 8-lane slot, because I think that's where most people who use this card is where they're going to need it, whether they realize it or not. And the reason I say that, we had a chance to talk with High Point, and when we were talking about taking a look at one of their cards on the Gigabyte TRX40 Designare, they said, oh, everybody's tested that on the X570. I said, you got to be nuts because you don't have a 16-lane slot. And they said, yeah. So you can kind of see where that conversation went. So they wanted to sell us a High Point card. I need one like I need a hole in my head. I'd be happy to look at one. I'm not going to buy one. I got other things trying to do for clients and other things I need for content creation and rendering. And as we look at storage, content creation goes two ways. One for video, which is all about rendering, and rendering is nothing about storage in terms of speed of storage. Whereas if you're doing audio, that's where something like this shines because you need the speed. Now, for those of you that are doing neither one of those, but more like virtual machines with databases and that kind of stuff, or artificial intelligence or deep learning, that's a different animal, different game that I don't have a lot of experience with. I can tell you how the hardware works. You can tell me about the applications and what you use. We look at the specs and see how that plays out. Content creation, I understand. Audio, I understand. Video, I understand. So that's what I try to relate. I'm eager now to get this installed, and I hope that little bit of information helps. Now then, the next question. I'm so excited about getting this in. I forgot two things I've got to do. One, the USB cable for communication, and they don't say anything about software, so I'm curious to see how this is going to, how that's going to work. And number two, about the power adapter, so I've got to figure that out. USB cable and our two power taps. Because I'm going to need a 6-pin power tap, I may have to procure a power tap from something else that's not power crucial right now, which would be Thunderbolt. So I'm going to keep those handy. But if I have an issue trying to pull power that way, I can always use this and pull power from the bus, because this adapter lets me do PCI Express. But I would much rather pull power from a power tap. But I ordered all these extra parts because I wanted to have everything to show you guys how this all works. But I got to tell you, the big surprise for me in the box was the heat sinks. I didn't know how they did that. Now my greatest concern about these heat sinks, that almost looks like double-sided tape, and that has me a bit concerned. Because as you know, I've got to be able to pull these out and put them in another machine. So I'm going to pull one out. Let's see what we're dealing with. Now based on the price of this card, I'm a little bit apprehensive about putting these pads on, because if that's some kind of a double-sided tape to make those stick, what kind of longevity is that going to have? Will it sag, and will I be able to get it off? Based on the thickness and the size, I'm not expecting much performance out of these, but I need to try them and see how they work. The reason I mention this is because of all the heat sinks we've looked at. We have better options for heat sinks, but that's 6 heat sinks. The least expensive option would be just the copper plates, which we considered for a laptop. But to use those, and we have clearance, let's look. We have clearance, as you look here at the back of the board, where we will clear components, even on these drives with double-sided memory. We'll clear the components, but the problem is, you take that times 6, that's 6 heat sinks. That makes an expensive card even more expensive. That's my point. And the cooling solution that comes with these, I think, should be of a higher quality. This looks almost like a micro connector's heat sink. It's aluminum. Let's see. No thermal bands came with it, just an aluminum with a pad. And if we were to change out the pads for something with a higher W/MK value, they wouldn't stick the way I guess these are going to stick. But my concern is if I'll be able to unstick them. We're going to see. The other thing I could do is test them bare, but I'm going to go ahead and test them with their heat sinks, because this is a stock setup. We need to know how they perform with the heat sinks. Then we'll look at our charts. We have established parameters that I'll get to and I'll show in the chart, since we're going to use these heat sinks, because it's going to be relevant. And yes, the machine is going to stay open, and yes, we could improve the thermal conductivity if we took the labels off. However, it's not appropriate and not wise to take all the labels off, because a good example is like the Sabrent. The Sabrent drives are like a metallic label, and that's part of how they do their heat distribution. And besides, I wouldn't know who's on first, because we do a lot of testing, and it would really mix things up for me. So no, that's a choice. If you want to go down that road, we don't. So we're going to see how this is going to work. I need to ask them what the W/MK value is on these heat sinks. Peel those off. Okay, heat sink 1, 2, and 3. And there's no way to get compression on those. It is what it is. How effective are they going to be? I don't know. We're going to find out. But again, we're going with a stock installation. That's what we want to find out before we try to customize anything. So I want to point that out. Now the one temperature we've looked at on one of the drives was the one drive that got the hottest, and that's the WD Black SN850. So that's the one we established as our baseline drive. So we'll look at that chart when we get to that point and compare. And I'll bring up the chart so we can look at the operating temperature for that particular drive. Again, the WD Black SN850, which was the hottest and the fastest. And as we've seen, the faster we go, the hotter we get, which is going to be particularly important as we go PCI Express 5.0. Another part that I did not see that I just now found in the box, fascinating, with 2 bits. Oh, it's even got a cap on one end. Check this out. So I got a place here. I can put those bits. Very nice. And that looks like a hex bit that's got a magnet in there, so it'll just drop in. I thought maybe it had a lock to it, but it doesn't. So I've got 2 bit tips here. One is a #1 Phillips tip. It's a hex shape on the outside. So I thought maybe the center had something to do with these. Looking at this on camera, I don't see that these will help. No, those still have to be finger tightened. So where this would come in handy, because here's your Phillips screw for the back side, and the other connectors on this side, and the fans are set with screws, so that #1 Phillips will work with that, and the Phillips will work with that. So I'm not sure where we'd use this. Only place I can see would be right there. Nope, doesn't fit that. And the I/O connector on the bottom, that should fit that. That's too big, so someone needs to double check their fasteners. But the size of that looks like, yeah, those are about the same size. So that would be 2mm. What that needs is this size to fit in that, which they don't include, which is a 1.3mm. So I don't know what that bit is for, but one bit's useful, the other is not. Details. Okay, so we have 2 cables we've got to plug in, one for power and one for USB. We have our power tap and we have our data cable plugged in. And both of those are keyed, so they only go in one way. Okay, for the Squid carrier board, the one we're looking at, I'm looking specifically, I did a search, real-time performance and temperature monitoring via the USB connection. Easily removable cooling fans, open concept, effective heat dissipation. Now it says here by 16 or by 8, upstream connection to the motherboard, and by 4, connection to each of the 6 M.2 drives, 8 gigabits per second. Standard 1 slot, easy plug and play. I'm curious about how we're going to monitor that. Okay, there's 3 instances of USB on this page, and according to what this tells us, one of the options, option 9, it's been a long time since I've looked at this, so I'd forgotten about all this. Real-time performance and temperature monitoring option via USB connection requires the Silicon Labs CP2102 bridge driver installation and one of the USB cables. Okay, so we've got a driver we've got to install. I didn't remember that. Good to know. So I'm going to get the thing installed, and then we'll see about downloading that driver. Because we have to remember, once we do this with RAID, we've got to install Windows on it and pull the boot drive off. So, okay, we've done our unboxing. We've done our inspection. I think we've gone over everything pretty thoroughly. And let's do the installation. Okay, now remember, we have a 16-lane slot and 8-lane slot. We cannot install this card until we power up the machine, go into the BIOS, and turn off bifurcation for those 2 slots. So that's got to be done first. BIOS, settings, I/O ports, and bifurcation on PCI Express with 16_1. Enter. Turn that back to auto, which should be the same thing as by 16, but that had to be set manually. And PCI Express by 8_1, also that one. We'll change that back to auto so we can do both our tests in succession from one slot to the other. Now what we need to do is reboot. So the next thing we need to do is F10 shows the 2 things we've changed. And if anybody's interested, I will show you right quick F2 easy mode. And up here in the top left, Gigabyte TRX40 Designare, we're on BIOS version F4Q. And we are running a 3970 processor with 256 gigs of RAM. So F2 again, F10, save, exit. And when everything comes back, since we've done the BIOS for both settings, we'll go into Windows, do our thing. Even though we have dedicated resources, and even though we can bifurcate a slot, which we do with all the cards, because this has a PLX chip, it has bifurcation built in. So we've turned bifurcation off, so we can see 6 drives. Okay, we've gotten through post, now we're headed into Windows. I want to do a full boot, power back down. System booted successfully. Now we're going to shut down, power off, and while I'm waiting on that, I'm going to download this driver. So from this link, we'll go to Silicon Labs. That takes us over to this link, and we're looking at the CP210X USB to UART bridge. And a UART is a universal asynchronous receiver transmitter. UART bridge drivers are required for device operation as a virtual COM port to facilitate communication with the CP210X products. Fascinating. So that's the VCP driver feature and benefit. We'll go to Downloads. We'll download the CP210 Universal Windows driver, and this is dated from January the 13th of 2021, version 10.1.10. And there's also a driver with a serial enumerator. We're just going to go with the universal driver. It's the latest version. I'll create a folder. We'll call it Drivers. Put a copy of that. Now I've got it on my thumb drive. Then we'll take it over to the other machine, get it installed. Okay, power off, drain power, done. Pull power. That way we don't have to worry about anything. Power's drained, power's off. Now we get the card in. A lot of work for 6 drives. Let's see. Card's installed. We'll get it secured to the bracket. And we can get a good look here. We have ample clearance between that card and the CPU because we're in the first 16-lane slot. And our second 16-lane slot is a 2-slot wide EVGA RTX 2080 Ti. And in the first 8-lane slot, we're going to leave that empty. We've unbifurcated it, so when we change the connector on here, we can try it down here and compare performance. Because I think more people are going to need it there than they will there, just based on my experience. And then our second 8-lane slot is a Gigabyte Titan Ridge Thunderbolt 3 card. And I'm going to leave Thunderbolt connected as far as the device. However, I'm going to procure power from that for the time being so that we can supply power to this card so I don't have to get out another cable. Keyed, of course, 1 8-pin power tap, and I'm just going to let that sit right there. Now the tricky part is the USB cable, because I've got to get to a USB cable on the motherboard, which is right up next to the power supply, which means I've got to pull the GPU and Thunderbolt to get to that, because USB 2 is right under Thunderbolt. Okay, we want to pay particular attention to which USB connector we're using, because remember, Thunderbolt 3 has to have USB. Okay, we've got our USB 2 cable connected for the Amfeltec card, and we made sure we still have our USB 2 cable connected also for Thunderbolt. It's amazing at the stuff that needs a USB 2 header on a motherboard. For motherboards to be removing those, we need them. We should not have to use other devices. Okay, to reiterate, GPU is reinstalled, Thunderbolt 3 is installed, we have USB 2 header connected. We made sure of that for Thunderbolt 3, and we have the USB header connected so we can monitor this card. I'm curious to see what that looks like. And we're procuring a power tap from Thunderbolt 3 for right now. There's nothing on Thunderbolt that needs power, but I want to see if the drivers play nicely with each other. So I want to keep Thunderbolt 3 installed. And we want to make sure the fans are clear on the GPU from all the monkeying around we've done. Okay, we're good to go. Now, get video plugged back in, power plugged back in, turn on, energize. Oh, we have more lights. Not only do we see power to the GPU, on the motherboard we also have our postcode, but we'll hear our PC speaker. We also have lights down here. I wish you could see them on the Amfeltec Squid card. We have a row of green lights, a red light, and a row of amber lights. I think all you can see that one little, right there at the bottom, you can see one red light, you can see the green lights, and then you can see that row of amber lights. I don't know if I zoom in on that, if I can make that any clearer. Yeah, I've got to hold the machine up, cock it a little bit for you to see that. Red light, row of green lights, and then that row of amber lights right there. Okay, Windows is up. Now we got a driver. Okay, I've copied the driver. I'm going to extract. We have some release notes. Silicon Lab Virtual COM Port, Universal Driver. This says the VCP driver is automatically installed by Windows Update with alternate PID values. Those are not default. Otherwise, unzip the file. You'll have a directory containing the driver, installer files. And if Windows prompts you to install a driver, use the dialog to browse for the driver located to this folder. In a manual install, double-click and run the installer. Follow the instructions. And there's our installer. What I want to do right quick, first of all, is take a look at Device Manager and see what it sees. So we'll go to Control Panel, Device Manager. Yeah, what Windows sees, this is odd. What Windows sees right now is a serial mouse. As I double-click on that, the Silicon Labs, the CP210X USB to UART bridge, COM3. Okay, curious. Close that and close that. I want to go ahead and execute and run the installer, and then we'll follow the instructions. I'm curious to see if this helps. Silicon Labs device updated. Well, that was quick. Port 08-2021, device updated. Finish. Okay, I'll go back to Control Panel, Device Manager, and we're good. And right there under ports, Silicon Labs CP210X USB to UART bridge COM3. Success. Now I'm curious about reading it. Real-time performance and temperature monitoring. We should be able to see that. Let's see what hardware info sees. Do our thing. Okay, hardware info. Hardware info 64. 64-bit mode, sensors only. So we'll see our smart telemetry thermistors. So I'm going to look around and see if we see something with a UART besides those 6 drives. Okay, there's the boot drive. Seagate FireCuda 520. There's the WD Black SN850. There's the Samsung 980 Pro. And I'm going to go down the tree and start with that drive first. And then there's our 4 Sabrent rocket drives. So we're going to test 6 in a row. In terms of sensor data, in terms of that card, I don't see anything about a COM port. I would have thought, since we've installed the driver, so I'm going to do some research on that. I'm seeing this for the first time like you guys are. So if anybody else wants to look into it, be my guest. But I don't see anything that deals with a COM port. Okay, let's queue up. We can only have, I believe, 4 of these on screen at a time. So we're going to start with the WD Black SN850. We're looking at the minimum, maximum, and average. Our starting temperature is 39 degrees. On the Samsung is 34. And on the Sabrents, we're at 32, 36, 32, and 31. Hottest drive being the WD Black SN850. And let's go check our drive assignments. So Windows flag E, this PC, and D drive is WD Black SN850. Samsung 980 Pro is now J drive. Wow. So there's a difference, I guess, in the way those connectors are set. I did not look in the BIOS because that does not necessarily mean that's the way they're going to be. One other place I can look, and I'll minimize. Let's go to Control Panel. We'll go to Administrative Tools. We're going to Disk Management. So Computer Management and Disk Management. Let's see how the drives are seen. Okay, disk number 1 is WD Black. Disk number 2 is the Samsung. So I think we're correct on the connectors, but the drive letter assignments are odd. Okay, we'll close all that. Just double checking. And of course the other place I could have looked was in the BIOS, but I didn't. I'm eager to get this thing tested. So we're going to start with D drive, then we'll go to J drive. And remember, those are on opposite sides of the card. That may be why the drive letter assignment's different. I'll ask and see if I can get some clarification on that. Okay, we'll close that. WD Black SN850. And we have to remember the size of the drives. D drive, it's a 1 terabyte drive, so we're going to do a 1 gigabyte test file. And when we go to the other drives, because remember J drive, this is the last drive, but when we check the other drives, those are 2 terabyte drives, so we'll take the 2 terabyte drive and do a 2 gigabyte test file. Not exactly apples and apples, but it's as close as we can get. So, to reiterate, 1 terabyte drive, 1 gigabyte test file, all. We're going to do this 6 times. So right now we're on a PCI Express +16 slot. The card is self-bifurcated, and this establishes what the speed we're going to get through that PLX chip, which, to reiterate, is about 3,500 megabytes. All these drives should come in at 3,500 megabytes. If we didn't have the PLX chip, or if the PLX chip were PCI Express 4, then we should be capable of somewhere around 7,000 megabytes, whatever the drive is capable of. Remember, the WD Black SN850 and the Samsung 980 Pro are both PCI Express 4.0 second generation, so they're capable of 7,000 megabytes. But due to the restriction of the PLX chip at PCI Express 3, let's see if all 6 drives test out close to the same. And we'll see how we do on heat. All right, test is complete. We've established through the PLX chip we're about a little over 3,500 megabytes on the first drive. And our minimum on the temperature was 39 degrees. Our maximum is 57, which is acceptable and adequate. I'll get to the spec sheet when we get through this and we'll look and compare. We're within acceptable parameters with that stock heatsink. Now we're going to go to drive number 2, the Samsung 980 Pro. We have 2 thermistors, the primary and the secondary, and the secondary controllers on the controller chipset on the M.2 NVMe drive. So we're going to look at the temperature on the primary where it'll get the hottest, and let's see where we go. So that would be drive letter J. Let's double check. Windows flag E, this PC, and Samsung 980 Pro is J drive. So again, J drive is 1 terabyte, 1 gigabyte test file, all. Highlight. Let's see how we do. Fantastic. Test number 2 is complete. We are at a maximum of 45 degrees. That's even better. Like that. Okay. Now the next 4 drives, these Sabrent Rocket 4.0 2 terabyte drives, we'll go and we'll bring this screen down just a little bit so we can get all 4 of these in succession. And we'll take them in order. F drive, 2 terabyte drive, we'll do a 2 gigabyte test file. All. And we're watching our minimum, maximum, and average temperatures. Okay, drive F test complete, and the drives now are not sequential in their numbering. So the drive we just tested was not this first one that we thought we were testing, but right now we're testing this second drive. find that quite curious about the order of the drives. Anyway, we are at 54 degrees, which still is an acceptable parameter. And you can see what we're getting on our reads and our writes. So the list I'm going to maintain, I would like to keep them sequential. So I'm going to put this down. Instead of being drive number 3 is actually drive number 4. And that's going to be at 54 degrees. So that way when we look at the temps, when I repeat them back, I'll repeat them sequentially according to the order in hardware info. So now what I'm curious is, let's go to drive G. We'll figure out which drive it is. 2 terabyte drive, 2 gigabyte test file, all. And whichever one of these shows a maximum temperature or the one that rises, that'll be the one we tested. I'm guessing it's going to be that one right there. Wow. Okay, next test complete. That would be drive letter G. And in the sequence, that would be drive number 5, 44 degrees. So if 44 degrees was our max, and you get an idea of what our read and write is, just under 3,500 megabytes. Let's go to the next drive, drive letter H, 2 terabyte, 2 gigabyte test file, all. See which drive we're testing now. Looks like that one. Fascinating. Test complete, 49 degrees. Speed test out about right, as to be expected. And that was drive letter H. And one more drive to test, which we expect will be that drive. So we'll go to drive letter I, 2 terabyte drive, 2 gigabyte test file, all. Highlight. And that test is complete. We are at 48 degrees. And that drive is identified as drive I. And the speed, of course, is respectable for a PCI Express 3.0 PLX chip. Okay, that's the first set of tests. Remember, we're on a 16-lane slot, bifurcated. We have 6 drives. Now the next set of tests, what we want to do is look at this in an 8-lane slot.